All right, and someone posted two questions about section 2.7, problems 13 and 15, and I'm glad these came up because as I'm looking at them, I'm realizing we didn't really do a problem like this in the notes on 2.7, and I should probably add that in there because this is kind of important stuff. Okay, both of these problems involve a limit as x is approaching negative infinity, and as I said towards the end of the video on 2.7, the math that we do when trying to evaluate limits at either positive or negative infinity is different and less precise than everything you guys have been used to doing for the last 5 years here. So there's a quick way, and then there's a slower, more formal way to do these problems. I'm going to show you the first way here in blue, and then I think I'll switch to green maybe and show you the more formal way. The quicker way to do it is to remember that since we're taking a limit as x is decreasing without bound, becoming a hugely negative number. Think about negative 1,000, negative 1,000,000, negative 1,000,000,000. We have terms here that are not important because the value of x is getting so big in terms of its absolute value. We can ignore the -9 and the +3 because they contribute so little to the value of the function as x is getting either really, really big or in this case, really, really small. So what happens now, guys? Really, the 7x squared on top is the only important term, and the 4x on the bottom is the only important term. So this becomes the same now as the limit as x approaches negative infinity of 7x squared over 4x, which simplifies to just a 7/4 x. And if we were to let x approach negative infinity, multiplying the 7/4 by infinity doesn't have any impact there at all. We just need to realize that as x is getting to be a hugely negative number, this number here, the value of 7/4 x, is going to approach negative infinity as well. And that's the answer to this problem, guys, negative infinity. Now, if we thought a little bit more about this and if we wanted to do it more formally, here's what I would tell you guys to do. The trick here is to look at your denominator, the 4x plus 3. Look for the highest degree that you see of x, which is 1. And what we would do then is divide every term in the entire expression, numerator and denominator, by this x right here. So if I do that, I divide that by x, and that by x, and that by x, and that by x. Let's take a look formally now to see what that does for us. This now becomes the limit as x approaches negative infinity of the numerator, 7x squared divided by x is just 7x minus a 9 over x. Yeah, I know, I just made a simple fraction complex, but there's a reason for it. And down in the denominator, we end up with a 4 plus a 3 over x. And now what I want you guys to realize here is that this term right here and this term right here, if we think about what happens as x is approaching negative infinity, your denominator increases without bound, or in this case decreases, and the numerator stays the same. The limit of both of those circled fractions with x on the bottom is going to be 0. And that's the reason why you can do what I explained up here in blue. That's the reason why you can simply ignore those terms there, because their limits, once you divide them by x, just becomes 0. So again, we end up now with the limit as x approaches negative infinity of 7/4 x, and there's the answer right there again. Just got a slightly different way of getting there. So that's a little more formal of a way of doing it. It's important, though, we divided everything by x because that was the highest degree term in the denominator. If you did it for the whole, the highest degree term in the entire expression, which would be the x squared, your problem there would be, don't change this on your work, everybody, but if you divided everything by x squared, here you'd end up with a 4 over x and a 3 over x squared. Now when you let x actually approach infinity, you'd end up with a 0 plus 0, and your denominator is 0, and that's no help to us at all. So that's really the way that we would handle a problem like 13. So let me go ahead and do 15. Probably wouldn't be a bad idea for you guys to stop the video right now and try this one on your own if you think you understood 13, and then come back and check this. But anyway, here we go for 15. Again, only because it's a limit, as x is approaching plus or minus infinity, we can ignore the constants and focus only on the highest degree terms. So this is the same, dang gummit, this is the same as, let me get rid of that junk, sorry, as the limit as x approaches negative infinity of, really, this is a 3x cubed over 4x. So I'm going to put a 3/4 out in front, and x cubed divided by x is going to leave us with an x squared. Now from here, again, you can kind of just think of the constant multiple rule here and bring the 3/4 out in front. And this time, unlike the last problem, x is approaching negative infinity. It's a negative value, but we're squaring that negative value, which is going to turn it positive. So this is basically going to be 3/4 times positive infinity, which is just going to be positive infinity.